So this video is on how to write a good research question for your chemistry IA. This is based on the 2025 specification. So first off, this is the information we're given to help us mark, and also supply to you guys so that you can hopefully gain all the marks possible for this. So research question with context should contain reference to independent dependent variables or two correlated variables, include a concise description of the system in which it's embedded, and include background theory of direct relevance. We've got some of the methodological considerations, selection of methods. So you've got to talk about why you choose to select the way that you do for measuring independent dependent. If you're using a database or sampling, why you made those choices, and decisions in terms of scope, quantity and quality. Now that has come in, or this is more in depth than it used to be. Identification of control variables, choice of method of control, and recognition of safety, ethical and environmental issues. But first off, I'm going to focus on the research question. Okay. So here's an example of a poor research question. And just underneath this is the strand's description for getting the top grade. The research question is described within a specific and appropriate context. This example at the top would not be getting it, maybe one or two. Okay. So why is that? Well, first off, I'm going to give you a little checklist of things we would be looking for in a research question, and then talk you through how we would improve that research question that we looked at the beginning. Okay, so first off, research question is clear, precisely formulated without ambiguous terms such as efficiency or suitability. The research question is chemistry focused. Okay, it can be a little bit tricky when things are kind of bordering into biochemistry, proteins, enzymes, that kind of thing. You can still do an IA that involves enzymes, but you need to be focusing on the chemistry rather than the biology. Research questions includes clear, specific, independent, dependent variables. So how does mass of magnesium affect, not how does amount of magnesium affect. And research question is not describing simple brand analysis of food, cleaning, pharmaceutical products. So what do I mean by that? We don't want something where we're looking for which is the best cleaner. First of all, because that's an ambiguous term, what's best. But we're also, for you guys to access top band throughout, you want to have a continuous independent variable. So not comparing categories, comparing this with that. Instead you want, as I change this is the effect on the dependent variable. Okay, so looking for something where you can get a line graph at the end, or scatter graph. You can get line of best fit. You can describe the pattern and predict what would happen if you continued the pattern, or be able to kind of estimate what would happen. So I'm going to come back and have a little look at that question that I said wasn't very good. And I'm going to remind you of what the information is from the IB that we got. Research question with context should contain reference to the dependent, independent variable or two correlated variables, and a concise description of the system in which research question is embedded, including background theory of direct relevance. Now I would actually recommend going through all your control variables first before completing your research question, or at least definitely coming back and looking back at your research question once you've done your control variables. So why is this no good? Well, first of all, amount. Amount doesn't mean anything. Mass per 100 grams or mass per concentration. Are we looking at the coffee, or are we looking at the caffeine in the beans, or the coffee made from the beans? I I came up with a research question from this, and I'm still not completely decided that it's a perfect research question because I'm not going to do it. I haven't done all the background that you would actually need to do. So this is my example of a much better research question drawn from that initial one there. So how does roasting, and then I've given the source, the name, the type of beans, coffee. I just looked this up on Amazon, the random one. I'm not recommending, I can't drink coffee, so that's not an endorsement. I at 200 degrees, so roasting time is the most important control variable, really. Well, the dependent variable is the roasting time, but the roasting temperature obviously would make a big difference, so we need to control that. 0, 10, 20, I just I picked these because I assume normally you roast for some significant amount of time, so we want a big enough time that we actually might impact our amount of caffeine, but obviously we are doing that within the school labs, so I wouldn't want anything that took too long, or I wouldn't be, 1 day, 2 day would be pretty hard to do. And then I decided to make it the amount of caffeine in the coffee rather than the coffee beans, because you can't be sure you're extracting all the caffeine from the beans, so this is a more correct, this is what I actually be measuring. And I said I'd make 200 cubic centimeters of filter coffee from 50 grams of ground coffee, and then I kind of summarized how we determine that using excess iodine with sulfuric acid, and then you back titrate using sodium thiosulfate to see how much of the iodine reacted with the caffeine. Okay, this is not 100% perfect because I haven't done the background properly. I also don't drink coffee, so I have no idea what a suitable amount of coffee is, but these would all be things that you would kind of work out, maybe do a trial and work out what would be suitable. Okay, we could even go into a little more detail. You may make 200 cubic centimeters, but you would only titrate 25 cubic centimeter aliquots of that, for instance, and you might put in how much iodine you are adding, etc. Okay, but all of that is something worth coming back and kind of double checking right at the end as well. So once you do your control variables, you might want to improve it, and then once you've actually done your whole experiment, double check that you didn't do something on day one where you went, oh, this amount doesn't work, and completely rejig everything. Make sure you go back and check your research question. Okay, right, so that's everything for research, and I'm going to move on and look a little bit at background. So background is you putting your experiment, first of all, in context. Now that no longer means personal engagement. Okay, but I'll carry on with this coffee theme. Now I started it, so I might start off with in the UK, this many people drink coffee, or it's become increasingly popular. I would obviously have to quote some numbers on that, and talk about maybe why it's important that we know the amount of caffeine impacts caffeine might have on somebody's system, for instance. Okay, so background, it's not I like coffee anymore, or I'm interested in coffee. Instead, it is setting that within the context of how this might relate to people's everyday life. Okay, so background. First off, I would be looking that we put it into context, and need and importance is clear. Okay, so that's, like I said, with the coffee. Try and just tell me where this would fit in the world. Okay, remember to do it third person passive, please, as in coffee is consumed by, rather than I drink coffee every day. Please, appropriate and relevant chemical equations. This is a chemistry IA, so you should have your chemical equations, and it should be the actual ones that you are using. So don't give me any kind of HA for weak acid. Put the actual weak acid you're using as an example. We quite often get the equations that we use to revise from, but please use the real ones in the situation. So if you're doing lactic acid, give me the equation for lactic acid. Relevant quantitative equations that you might be using, though these can also appear when you do your processing. Okay. Expected graph. So what do you expect to find and why? With all of this, you need to back it up with references. Chemistry needs to be directly related to the research question. This sounds obvious, but you'll be surprised how often people get a little bit off track. Okay, so remember, I would be looking, again, for my example, I would be looking at researching the effect of heat on caffeine, what happens when it's heated. I'd be researching how much caffeine is in coffee. I'd be researching to see if anyone else has done a similar experiment and what they found, and use that to draw my expected graph. Okay, doesn't need to be very large, just a kind of sketch graph to give you an idea of what shape. You need to focus your background on chemistry and not biology. So I think this caffeine, for instance, you would maybe touch upon that people drink it to stay awake or to stay alert, but we wouldn't be interested in psychology experiments or measures on the effect of reaction time, because you're moving then into psychology and biology, and that's not what this experiment is about, and it's also not directly linked to the effect of temperature or roasting time on caffeine. I kind of mentioned this before, but generalized theory, if it's in the IB, please don't take too much time to explain it, because this is written for IB teachers. They know the IB spec backwards and forwards, so you don't have to tell them what a weak acid is particularly. Anything that's outside of the specification, you should go a little bit deeper in. But please don't try and reteach the person reading it stuff that you already know. Okay, occasionally people have used up quite large chunks for explaining from scratch what a weak acid is. So remember, if it's within the IB, you can go quite quickly and be quite concise, and then you need to be more in depth on anything that's beyond the IB. Background data should suggest that the experiment you're doing will actually have a result. Okay, that caffeine is temperature sensitive, for instance, and you should be able to formulate a hypothesis on the relationship, because your background data should hopefully tell you what to predict. Now, your hypothesis may be wrong. This has happened. We've had students where they've tested one thing. So especially with foods, what can happen is there's so many other substances in foods that you can find that if you were testing for the amount of vitamin C using an acid-base titration, well, you might find that there's other acids in the food, so that your prediction was completely wrong. Okay, but you should still be able to do a prediction. Don't worry too much if it's wrong. Well, you should be doing it accurate to the your background data, and so where it says hypothesis is scientifically accurate, it should be supported by your background data. Okay, if your actual results show no change or the opposite, then please don't try and force your data to follow your hypothesis. That is the results you got. Okay, right. Common issues I get with students in their background is poor referencing or no referencing. Remember, if you're saying something if you're giving me a chemical equation, tell me where you got it from. Okay. Again, if it's within the IB, the scope of the IB, you don't need this so much. Okay, again, but if it is anything outside, if I'm quoting the number of people that drink coffee in the UK, I need to tell the reader where I got that from. Research question does not match the conclusion. Now this sounds obvious, but the last couple of times I've done this, we've got right to the very end. So every year this has happened to at least one student. We've got right to the very end and realised their conclusion is not actually answering their research question. They didn't use the same units that were in their research question in their conclusion. Okay, so please be very careful with this. Research question does not have enough detail about the measurement methods. Okay, so tell us how you're finding it. Choice of IV is not justified. So why would you expect that roasting beans might affect the amount of caffeine? Have you got reason? Is there a reasonable expectation? So you need to explain why you have selected your independent variable, and dependent variable is more about explaining how you can use that to measure the dependent variable. You also want to look at explaining why you picked the range that you went for. So you have time considerations, you've only got 11 hours, but you also want them spread out enough that you can have a reasonable range of data. You might be limited if you're doing something where you're heating water, you're going to be limited by the boiling point of water, for instance. And it's very hard to maintain a temperature below room temperature that is not 0. So we can get to 0 using ice, but getting to 10 degrees is actually really quite hard. Okay, so I've put that in red. So variable, repetition, precision of measurements. You need to think about these when you're going through. I'll do a video on variables as well separately. So this last bit here, actually I'm going to come and do a separate video on.